Good afternoon, students. Am I audible? Am I audible?
Good afternoon.
Okay. For this semester, I'm Professor S.V. Fulari, Assistant Professor in Computer Engineering. First of all, I will give you my introduction because this is my first lecture to you. I am Professor S.V. Fulari, uh, Assistant Professor in Computer Engineering Department, working since 1999. Uh, 22 years experience in this teaching field. Uh, Normally, mostly I conduct only third year and final year students. I teach only till now. I taught for third year and final year students. Very few years I have taken this second year subject. Mostly I taught for third year and final year. Now for this year, for this semester, I am taking this your subject of principles of programming languages, and all of you are very much familiar from the first year. The teaching scheme as well as examination scheme for this subject is the same. Teaching three lectures will be there for this subject in a week per week, and teaching examination scheme will be in same examination, that is the mid same examination. 30 marks will be there, and 8 same examination, 70 marks will be there. This yeah, the prerequisite for this learning of principles of programming languages subject is that already all of you studied this. Already all of you have studied these fundamentals of data structures, object-oriented programming, as well as the fundamentals of programming languages. Assuming that all these three subjects, fundamentals of data structures, object-oriented programming, as well as the fundamentals of programming languages, concepts are clear before this. And software engineering, data structure and algorithms, and project-based learning. These three subjects you have in this semester. Uh, for that, it is in for that also these principles of programming languages subject is required. In these principles of programming languages, we have to learn what are the objectives are there for this subject. The objectives are to learn basic principles of programming languages. What are the basic principles are there for programming languages and programming paradigm? And also we are going to learn in this subject structuring the data and manipulation of data. Structuring the data and manipulation of data, computation and program structure. And after that we are going to learn in this subject that is the object-oriented programming principles, OOP principles, and using Java programming language. And to learn basic concepts of logical as well as functional programming language. Logical as well as functional programming languages. These are the objectives of what we are going to learn in this subject. After learning of this subject, what the students will be able to do. So in this, after learning of this subject, there will be to make the use of basic programming, to make the use of basic programming languages, how to use this basic principles, how to use these basic principles in programming languages. and the students will be able to develop a program with data representation and computations. The student will be able to develop a program with data representation and computations. Students able to develop programs using object-oriented programming languages. Able to develop programs using object-oriented programming languages and develop an application using inheritance, encapsulation, and polymorphism. So very basic principles are there already. You learned so many, and that is why the prerequisite for this course is given that fundamentals of data structures, object-oriented programming, as well as fundamentals of programming languages. You already you know the basic of all these questions of all these subjects. Um, Not for all the students, but also at the time of your first semester, this examination, online examination for the any one subject exactly. I hope so. That is the object-oriented programming (OOP) subject. I was the external examiner for you, for the direct SC students, not the regular students, but for the SC students. Most of the students were unable to, even if they know the answers, they were unable to give the answers properly at the time of oral examination. The simple questions I was asked to you: what is the compiler? What is the interpreter? Like these are simple questions. What is an object? What is a program? What is a flowchart? What is an algorithm? Such simple questions I was asked to you at the time of your this examination. But most of the students were unable to give the answer of this question. So at this level, you should know what we are using in the subjects. What are the things are there? At least that much is expected for you, right? That much is expected. So it is necessary that what you are learning in this, right? It is necessary to know what you are learning in the subject. Not only in this, in all the subjects what you are learning, that much at least you should know. Now in this subject there are also 6 units in like the other subjects, right? Now in the first unit we are going to learn the fundamentals of programming. Fundamentals of programming. Importance of studying programming languages. What is the importance of the subject in this? And what is the history of the programming language? What is the impact of programming paradigms? What is the role of the programming languages? What are the programming environments are there? What is the impact of machine architecture? What is the operation of the computer? What is the virtual? What do you mean by virtual computers? That part we are going to learn in the first unit, that is in the fundamentals of programming. Now, as well as along with this programming paradigms, also we are going to discuss in the first unit, that is the introduction of the programming paradigms, introduction to 4 main programming paradigms: procedural, object-oriented, functional, and logic and rule-based. These different 4 main programming paradigms we are going to discuss in the first unit only. What is the overall view of in this subject that I am discussing with you? In the second subject, this unit, we are going to learn. We are going to discuss the structuring the data. Structuring the data. computations and program. Structuring the data, computations and program. There is we should go thoroughly in this structuring of data. What are these? It means what are different elementary data types are there. What are different elementary data types are there? Primitive data types are there, character string types are there, user-defined ordinal types are there, array types are there, associative types are there, recorder types are there, union types are there, pointer and reference type. All these are the elementary data types. And already you have learned all these things. This is not so much new thing in these subjects. Now, expression and assignment statements. Expression and assignment statement. Arithmetic expression. All of you are familiar with this arithmetic expression. Overloaded operators. Type conversions. Relational and Boolean expressions. Short circuit evaluation. Assignment statements. Mixed mode assignment. This is what all we are going to learn in the expression and assignment statements. Statement level control statements. Selection statements are there, iterative statements are there, and conditional branching statements are there. So many control statements are there. Subprograms. Fundamentals of subprograms. What are the fundamentals of subprograms? Design issues of subprograms. Local referencing environment. Parameter passing methods. Abstract data types and encapsulation construct. Abstract data types and encapsulation construct. Design issues for abstraction. Parameterized abstract data types. Encapsulation constructs. Naming encapsulation. In the third unit, there is Java as object-oriented programming language. Overview part we will learn in the third unit. In the fourth unit, inheritance, packages, and exception handling using Java. Inheritance, packages, and exception handling using the Java. That part we are going to learn in the fourth unit. And in the fifth unit, multi-threaded in Java, that part we will learn. And in the sixth unit, logical and functional programming. Logical and functional programming, that part we will learn in the sixth unit. For this subject, Dr. R. Nageshwar Rao, Core Java and Integrated Approach. This book you can use. Dr. R. Nageshwar Rao. That is one of the best book for this principles of programming languages. And for the textbook, Herbert Shield, the complete reference Java 9th edition. That is also one of the good textbook for this subject. The complete reference Java, Herbert Shield. These two in these two books, Nageshwar Rao and Herbert Shield, almost all the contents which are related to these subjects are covered. This is what the overall structure of for this subject, principles of programming languages. Now, in the first unit, in this subject, the introduction part is there for this subject. Fundamentals of programming languages. What are the fundamentals of programming languages? Now, importance of studying programming languages. What is the importance of studying this programming language? It increases ability to express ideas. It increases the ability to express ideas. It is believed that the depth at which we think is influenced by the expressive power of the language in which we communicate our thoughts. It is believed that the depth at which we think is influenced by the expressive power of the language in which we communicate our thoughts. It is difficult for people to conceptualize structures they can't describe verbally or in writing. It is difficult for people to conceptualize structures they can't describe. Many times, many people are unable to describe it, unable to write it proper, right? So this may happen many times. The language in which they develop software places limits on the kinds of the control structure, data structures, and abstractions they can use. Languages in which they develop software places limits on the kinds of control structures, data structures, and abstractions they can use. Awareness of a wider variety of programming languages features can reduce such limitations in software development. Can language constructs be simulated in other languages that do not support those constructed directly? Now, improved background for choosing appropriate languages. Many programmers, when given a choice of languages for a new subject, many programmers, when given a choice of languages for a new project, continue to use the language with which they are most familiar, even if it is the poorly suited for new project. If these programmers were familiar with the other languages available, they would be in a better position to make informed language choices. So, greater ability to learn new languages. Greater ability to learn new languages. Programming languages are still in a state of a continuous evaluation. Programming languages are still in a state of continuous evolution, which means continuous learning is essential. That is what greater ability to learn new languages. Programming languages are still in a state of continuous evolution, which means continuous learning is essential. Programmers who understand the concept of object-oriented programming, which will have easier time learning Java. Programmers who understand the concept of object-oriented programming will have easier time learning Java. Once a thorough understanding of the fundamental concepts of languages is acquired, once a thorough understanding of the fundamental concepts of languages is acquired, it becomes easier to see how concepts are incorporated into the design of the language being learned. Once thorough understanding of the fundamental concepts of language is acquired, it becomes easier to see how concepts are incorporated into the design of the language being learned. Understand significance of implementation. understanding the implementation, understanding the implementation issues lead to an understanding of why languages are designed the way they are. Understanding of implementation issues leads to an understanding of why languages are designed the way they are. This is what understanding significance of implementation. This in turn leads to the ability to use a language more intelligently as it was designed to be used. The ability to use a language more intelligently as it was designed to be used. Ability to design new languages. Ability to design new languages. To more languages you can you gain knowledge of for more languages you can gain knowledge of the better understanding of programming languages, concepts you understand. That is what ability to design new languages. To gain knowledge of better understanding of programming languages, concepts you understand. Overall advancement of computing. In some cases, the language become widely used. The language became widely used, at least in part, because those in positions to choose languages were not sufficiently familiar with programming languages concepts. What is the history of programming languages? What is the history of programming languages? Computer programs, known as software, are instructions to the computer. Computer programs, known as software, are instructions to the computer. You tell a computer what to do through programs. Without programs, a computer is an empty machine. Without programs, a computer is an empty machine. Computers do not understand human languages. So, you need to use computer languages to communicate with them. You need to use computer languages to communicate with them. Programs are written using programming languages. Programs are written using programming languages. For example, machine language is there, assembly language is there, high level language is there. Three things it is distributed: machine language, assembly language, high level language. What we discussed here now, you tell a computer what to do through programs. What is a program? A set of instructions written for a particular task. A set of instructions written for a particular task. That is nothing but the program. Right. Now, most of the programs, almost all the programs we are writing in high level languages. Machine language, assembly language, high level language. Machine language, assembly language, high level language. Now, what is machine language? The language of a computer speaks in machine language. Machine language, the language a computer speaks in machine language. Machine language is a set of primitive instructions built into every computer. Machine language is a set of primitive instructions built into every computer. Machine languages are different for different type of computers. Machine languages are different for different type of computers. The instructions are in the form of binary code. So you have to enter binary codes for various instructions. The instructions are in the form of binary code. So you have to enter binary codes for various instructions. Program with native machine language is a tedious process. Moreover, the programs are highly difficult to read and modify. The programs are highly difficult to read and modify in machine languages, because the machine understands only the instruction in binary. Instruction in binary. That it means like 1 1 0 1 1 0 1 0 1 0 0 1 1 0 1 0. This binary, this instruction in binary, this machine can understand, and that is why it is the programs written in machine language are highly difficult to read and modify. Highly difficult to read and modify. Now next hour is the assembly language. Assembly language. Assembly language is a low-level language in which a mnemonic is used to represent each of the machine language instructions. Assembly language is a low-level language in which mnemonic is used to represent each of the machine language instructions. Assembly languages were developed to make programming easy. Since the computer cannot understand assembly language, However, a program called assembler is used to convert assembly language programs into machine code. Assembly language program into machine code. A program called assembler is used to convert assembly language programs into machine code. For example, suppose to add two numbers, you might write an instruction in assembly code. Add 2, 3, result. That's all. In assembly, the instruction for addition of two numbers, you might have write the instruction like this: add 2, 3, result. Assembly source file is there, machine code file is there. Assembly program, the program written in assembly language, the program machine can understand. In between these two, an assembler is there. This assembler will convert the program written in assembly language into the machine language. This assembler is one of the translators. Now, third our programming language is the high-level language. The high-level languages are English-like or easy to learn and program. Higher-level languages are English-like and easy to learn. High-level languages developed to overcome the platform-specific problem. High-level languages developed to overcome the platform-specific problem. Suppose, for example, the high level language statement that computes the area of a circle with radius phi. Area of a circle. How will you find out the area of a circle? What is the formula for calculating the area of a circle?
Pi r square.
Pi, exactly correct. Right. Pi, that is the 3.14. R, that is the radius. R square, that is the R into R. This is the correct formula for finding out the area of a circle. There are more than 100 languages in most popular are there. More are hundreds of languages are there in high level language. The high level language, we are writing the programs using the English like words, right? We are using program, the writing in program in high level language using the English like words. English like words. We are writing the programs in high level language. In the assembly language, we are writing the programs in using the numerics. In the low level language, that is the machine language, we are writing the programs in binary. In all these stages, machine level language, assembly level language, and high level language, different translators are there. In the programs written in high level language, to convert into the machine level language, for that assembler is required. The programs written in high level language into the machine level language, for that a translator is required, and those translators are either the compiler or the interpreters. We are writing the programs using the English like words that understands you and me. That the human can understand this, but computer of the machine that cannot understand this English like words, human words. For that a translator, it means obviously a translator is required. The programs written in high level language to convert that into the low level language, that is the machine language. Who converts this? Either the compiler, that is also one of the translator. What is this compiler? It means this is also one of the software which converts from the programs written in a high level language into the low level language. Interpreter is also one of the translator. Interpreter is also one of the translator which converts the program written in high level language into the low level language in the binary code, in the machine code, in which the machine can understand it. Most of the students already use the compiler. Till now, you are now in SE part 2. Am I right?
Yes, sir.
Now all of you are studying in SE part 2 now. Till now you learned the subject of computer in the first year as well as in the second year first semester. In these 2-3 semesters you have written, I hope so many programs. In the first year as well as in the SE part 1, you have written so many programs in different subjects, and you have used this compiler, no doubt in this. Whether writing for the programs in either in C or C++ or in Java or in any other languages also, right? You have written it. So for execution of these programs, all of you have used this compiler, no doubt in this. All of you have used the compiler. What is the compiler? Is the program written in high level language that translates to the machine level language, and when the machine will, if it converts, this is one of the translator compiler. But
Goodbye.